So in this video, we will talk about some of the concepts underlying applications of right triangles. Um, to start with, when we began the course, we were talking about degrees because we all are fairly familiar with how degrees work. You refer to angles in degree measurement. Then we started talking about radians. We talked about we need to switch to radians, we need to use them. So I want to recap why we did that. And it comes down to calculus. That's really the reason. This is pre-cal, so hopefully that makes sense. So the formula for the area of a sector that we came up with was basically we took the area of a circle and we multiplied by a ratio that represents what part of the sector are you using. Or really, I should say, what part of the circle are you using for this sector? So if we take the arc length measurement of the sector and divide by the circumference, this is a fraction that shows this is the portion of the circle that you're using. So if we multiply that proportion times the area of the circle, well, then we get, here's the area of the sector. So when we replace this with formulas in terms of the radius and the angle measure, S equals r theta, that's how we defined theta equals S over r, is how we define radian measurement to begin with, right? So if you take this equation, multiply by r on both sides, you get r theta equals S. So that's what arc length is. It's r times theta. So over here, r times theta over circumference is 2 pi r, right? Times pi r squared, the area of a circle. So now we get to do some cancellation. So this r, these two r's will cancel, and then this theta, I'm not sorry, theta, this pi will cancel with this other pi. So if we do a little bit of a rearrangement, we are left with that this equals 1/2 theta times r squared, or if you want, 1/2 r squared theta. I usually write it this way. Not sure why, I just seem to prefer it. Anyway, so when you use this formula for the area of a sector, theta must be in radians only because that is what we were saying up here, that we're using S equals r theta, but this is what defines radian measurement. This is not quite right for degree measurement. You know, if you had a circle of radius 2 and you had an angle measure of 45, 2 times 45 would not mean the arc length is 90. The radius is 2. How can you have an arc length of 90? That's way too big, right? Anyway, so radian measure is defined that way. So when you use this formula for the area of a sector, we are using radians only. Now this you need for calculus. So when you go to do calculus, and you go to apply calculus to trigonometric functions like sine, cosine, tangent, you need this formula. You can't. Maybe there's a way to do it, but the standard way, at least, that it's done is this is the formula that you have to use to get started with doing derivatives. That's the term. With doing the derivative of the sine function, you have to use this formula. Okay. So for that reason, we need to get accustomed to radians because in calculus you have to use radians. So that's why we're doing it. Just to recap that. I don't want to make this video 20 minutes long, but just to recap. However, in this section, we're going to start using, we'll use degrees again for most of chapter 4. Occasionally, we might use radians, but we're going to use degrees again. Why is that? Well, a lot of the application problems are things involving uh, using a map, locations on a map, orienteering. That if you're talking about going in a direction, you don't usually use radians. You talk about degrees. Like, oh, we need to go pi over 6 north. You don't say that. We need to go 30 degrees north is the way it's referred to in orienteering, right? So we're going to go back to degrees because for these kinds of application problems, that's generally what is used. So how do you do that? Like if you have let's say we have come on, trying to use the automatic line features. That's close enough. Close enough. Okay, so let's say this is north, south, east, west, right? And you're here. You need to move in a direction, and especially if like you're on a walkie-talkie or a radio and you have to tell someone where you're going, you have to refer to what you're doing, right? So let's say that we were going this way. It's not drawing very well. Let's do this. Yeah, let's say that's 20 degrees off of due north, right? We're going to go from due north, we're going 20 degrees east. You can say it however you want. Use whatever verbiage gets the idea across. You say over the radio, okay, we're going to go north, but we're going to go 20 degrees east, or we're going to go 20 degrees eastward of north. You refer to it however, right? You just say what you mean. But the standard way to write it is north 20 degrees east. You always refer to the north or south first, and then you give the degree deviation from due north or due south, and then you give, are you going east or west? Which of the two? So, so if I had one like this, let's say we had, oops, like that, right? This isn't quite 20 degrees off of east. Let's say this is, let's say it's 15 degrees, just to pick a number. I would not say east 15 degrees south. Now, if I said that, you'd probably figure out what I meant, or you'd ask me to clarify, but that's not the standard way. The standard way is I have to refer to north or south first. What I really need is I need this deviation from south, and out of 90 degrees, if I remove 15, I have 75 left. So that's the deviation from south. So this would be referred to as south 15 degrees east. Okay? So that is the standard way of referring to this. So in later examples, we'll be using this reference to work those examples. The problems will be stated in those terms, perhaps, and our answers need to be in those terms, perhaps. We'll get to those examples as we get to them. So basically, I wanted to remind you of, here's why we're talking about radians, because of calculus. We're going back to degrees. And then here is the standard way that we'll refer to degrees. And while we're at it, I didn't say it here. I don't think it's going to come up in these application problems. It does not hurt to say just a quick reminder. Let's put it here. Reminder. Although you probably all already know this, I don't probably need to remind you, but we'll just anyway. Pi radians equals 180 degrees. Just to remind you, that's how I work out the conversion between radians and degrees if I need to.